Hi kids, I'm really not at the school. It just looks like I am because I've built an exact duplicate of the lab. So the lab that you're going to do today is certainly not very high on the excitement level. Okay, trust me, it's not. What we're going to do is we're going to take salts, two of them. The first one is hydrated copper sulfate, which is CuSO4.5H2O. So when you have a hydrate, it just means that there's a certain number of water molecules attached to the salt. In this case, 5. But notice that this isn't like aqueous. This isn't dissolved. They're water molecules that are attached to the copper sulfate itself. Now, the other one is anhydrous copper sulfate, which is just CuSO4. So one of the things how you can always tell the difference is that the anhydrous copper sulfate is a lighter color, and the hydrated copper sulfate is a darker color. So hopefully you can see that on the camera. So I've got 3.200 grams of anhydrous copper sulfate. So in here I have exactly 50 milliliters of water. We're going to assume that the density of water is 1 gram per cubic milliliter or cubic centimeter, depending upon your preference. So we're going to assume that since we have exactly 50 milliliters, we're going to have exactly 50 grams. So I'm going to pour that into here, and this is called literally coffee cup calorimetry, because we're going to have 2 coffee cups stacked together. So that way we're going to try and keep that heat within the system so that there's no external exchange within the system. So this is going to be important. This is going to be what the water is going to be the surroundings. Dissolving of the copper sulfate is going to be the system. So I've got this in here. I'm going to measure this temperature, and we're at about 20 degrees Celsius. Okay, so that's the initial temperature of the water. Now, what I'm going to do is I'm going to add, this is going to be important. This is the anhydrous one. This is actually the second one. You can do the hydrated first, and I've already got that data. And this is going to be the anhydrous one. So I'm going to take this, I'm going to pour this in here, okay? So we started at 20 degrees, and then this thing is going to dissolve. And as it's dissolving, we're going to measure what happens to the temperature. So the temperature is up to, now we're up to like 23 degrees. So what's happening is that this process is releasing energy, which is why the temperature of the water is going up. We're up to 24, and this stuff is dissolving. So we can't observe what's happening on an atomic level, but what we can do is we can measure the impact that it has on the surroundings. So the surroundings are gaining energy, which means that this process of forming bonds between the copper sulfate and the water, and breaking bonds between the copper and the sulfate, that overall process is releasing energy. So we're doing this, we're up to about 25 now. And hopefully we can get all this kind of stuff to dissolve. See, this is the boring part of the lab, because literally there's no hoorah thing, is that you're just watching salt dissolve, which is kind of boring, but okay, there's some big chunks in the room trying to get broke up. But anyway, so we ended up going up to about 26 degrees. So it's all dissolved now, okay? And we're going to record that highest temperature that we're going to get, which is about 26. So what this means, and trust me, this will fall if you leave it sit there. So what this means, kids, is that you had 2 things that were happening. You're breaking the bonds that held the copper and the sulfate together. Okay, so you were breaking those bonds. But then they were also forming bonds with the water. So because of the fact that the temperature of the water went up, so when you look at your calculation of Q, this is going to be important, listen to me. When you calculate Q for the water, which is the surroundings, your final temperature is going to be bigger than your initial temperature. So when you look at Q equals M delta T C sub P, your mass is going to be the 50 grams of water plus the 3.2 grams of the copper sulfate. So your total mass is going to be like 53.2 grams. That's what you're going to use for your mass. Your change in temperature is like 4, 5, 6 degrees, whatever this is. It'll be on your data sheet. And then the specific heat of water, 4.18 joules per gram degree Celsius. So Q for the surroundings is going to be a positive value because my temperature final is bigger than my initial temperature, which is the opposite of what happened when you see the copper sulfate. The copper sulfate, that temperature actually went down, which made it an endothermic reaction. So this is an exothermic reaction. The water temperature went up. So in the process of dissolving the copper sulfate, the anhydrous, that means that the temperature went up. It's an exothermic reaction. Now, what you're going to calculate is delta H for the copper sulfate. So, and this is what hopefully you got out of yesterday's lecture, is that so Q for the water is a positive value. That's going to gain a certain amount of energy. We're going to assume that that was the energy that was equal to the loss by the copper sulfate. So Q for the copper sulfate is going to be a negative value, right? So Q for the copper sulfate is going to be a negative value, that same number. But then to get your enthalpy change, and this is what you're ultimately after, is the enthalpy change. You're going to take the Q for the surroundings, which is going to be a positive number, switch the sign, make it a negative value for the copper sulfate, and then you're going to divide that by the number of moles of copper sulfate. So you got 3.2 grams divided by the molar mass, which I'm going to have on the lab. Then you get the number of moles. So you're going to take the Q for the copper sulfate, which is going to be a negative value, divided by your moles, you're going to negative delta H, which means it's an exothermic reaction. The first one with the hydrated copper sulfate, that temperature went down, so Q for the water in that situation then is going to be a negative value because the temperature went down. So Q for the system is going to be a positive value. You're going to divide that by the moles. That's going to be a positive delta H. So the first delta H with the hydrated copper sulfate is going to be a positive delta H because it's an endothermic reaction because the water temperature went down. Delta H for the second one is going to be a negative value because it's exothermic because the temperature went up because it lost energy. I'll explain more about it, but I just wanted you to kind of get an idea of what was going to happen with the lab. So that's the story. See you, kids.